Welcome to SAP CAP in Flight, BTP Cloud Foundry automated deployments with Azure DevOps. I'm Patterson here, BTP Cloud Sherpa. So the goal of this session is to understand why creating CI/CD pipelines for SAP CAP developments is both important and beneficial. And also we want to learn how Azure DevOps can help you on your CI/CD journey. And we're going to see a couple of examples of creating a simple pipeline and an advanced pipeline in Azure DevOps on top of a CAP application. And at the end, you're going to get access to the resources to go away and try them yourself. So one of the things is everything I show here is available in the free versions. So an agenda, introduction, followed by the benefits and the problems that CI/CD solve, onto what is Azure DevOps, and then the two examples, the simple example, the advanced example. The simple example, I'll really deep dive into it, and the advanced example, give you enough information so that you can go away and try out what I share for yourself. And then hopefully wrapping up with a conclusion and a couple of minutes to spare for any questions, etc. So onwards, who is John Patterson, BTP Sherpa? So I have 25 plus years SAP development experience. I work for many of the big blue chip customers throughout the world. And the last 10 years, I've been helping customers reduce the friction associated with learning and adopting new technology. And lately, that has incorporated SAP Cloud Application Programming. And so the Sherpa is a play on words. So Sherpa is somebody who helps people lift the heavy baggage while they journey to the clouds. And so what are CI/CD pipelines? So SAP CAP development is basically the lower barrier to entry for developers, and we'll be able to go off and create lots and lots of developments. And with the scaling out of all the developments, we really need to have some kind of process and governance in place to ensure that what we're developing is A, consistent, and B, is fit for deployment and is not going to break things. So what the CI/CD pipeline is continuous integration, the ability to push your changes regularly to a Git repository and test them. And the continuous delivery or continuous deployment is the ability to take those changes and successfully move them on to other environments, be that QAS, pre-production, production, etc. And last, why Azure DevOps pipelines? So, like I was saying, I've been helping teams for the last maybe 10 years. Starting with Fury, we noticed that a lot of customers already had their own build set up back then. So it would be Team Foundation Services, and it was based on the Microsoft product back then. And then they moved over to Azure DevOps. And one of the advantages of Azure DevOps in Australia is that it's actually hosted in Australia. So you think about the products that it competes with, Bitbucket and GitHub, and even the SAP CI/CD service. Those aren't hosted in Australia. So if you're a government agency or a large enterprise with sovereignty requirements, the ability to run pipelines as well as host the repos for those pipelines within Australia and within your sovereign boundaries is very important. So what are the benefits and problems that CI/CD solves? So efficiency, essentially it streamlines your development, reducing the wasted time and effort. It creates consistency, ensures uniformity across all your applications. The builds and the deployments all are very consistent. It promotes quality assurance. automated testing enhances the reliability of the software that you're creating. It speeds up the development process. So automating obviously makes things faster. Scalability, like we said before, the CAP, because it's a lower barrier to entry, there's going to be a lot more developers doing it, and therefore we want to be able to easily increase the workloads that not only we put on the pipeline, but also on BTP, and be able to scale and have that consistency, efficiency, and conformity. Security is front and center with a lot of the customers I work with, especially around compliance, making sure that you're not introducing any kind of vulnerabilities into your code or into the systems that customers use. We've got risk reduction. If you're working for a big enterprise, you really want to reduce the risk of deploying an application that's going to break something, especially when you've got tens of thousands of users who want to do something, and you don't want to impede on that. Traceability and auditability. Again, back to the compliance, the ability to know what was deployed and have a log of how it was made up and what was in it before it was built. The reproducibility, we want to be able to easily recreate the past build or releases. And last but not least is continuous improvement. We basically get fast feedback from these pipelines, and they give us the ability to basically enhance and optimize and make improvements to the source code based on that feedback. So next is what is Azure DevOps. So essentially, Azure DevOps is a collaboration tool hosted by Azure in the cloud. It's made up of artifacts. Now, artifacts you could think of as being like hosting your own NPM or Maven dependencies, or even Docker dependencies. Test plans is a tool for planning and managing and tracking testing efforts, be that manual or we can even automate some of the testing. Boards, job board, Kanban board, very similar to Jira, the ability to track work in progress from to-do to production. Pipelines is the continuous integration and continuous delivery, and that's the pipelines tool. And then last but not least is the Azure repos, which is the version control system, the Git repository built into Azure DevOps. So now, overview of Azure DevOps. So now I'm in my Azure DevOps account. Like I suggested before, it's the free version. Everything I need to do is in here. I think the only real limitations are when you pay for the service, you get access to better resources, and you can parallelize your runs. So basically, make your pipelines run much faster. So in here, we can see on the left-hand side, we've got dashboards, we've got wikis, we've got repos and pipelines. These are the two that we're going to focus on, is the repos and the pipelines. So first, we want to go off and create a new repository. So we create a new repository. We give it the name dev test and press create. So very similar to how GitHub or a Bitbucket would work. Then we click on the repository, and repository. Yep, we can see the README in there, and now there's an option up here to to set up a build, and this is how we would create our CI/CD pipeline. Click on the create build. We can see that we can generate a starter pipeline. We can use an existing pipeline, or there's various other pipelines available. We've also got the ability to go to the marketplace up here. So we browse the marketplace, and inside the marketplace we can grab extensions or other pipelines or other tasks. For example, I'd search for SAP. There's a task in here for running static app analysis, another one for reporting test results. There are lots of extensions available, but for now, let's create a starter pipeline. So it's created a YAML file, Azure pipeline YAML file. It's the pipeline can be triggered on any commit to the main branch which we're on. We're using the default Ubuntu virtual image. Think of it like a virtual image as a build pack. It has lots of resources included in it, and we can have access to Windows or iOS, or there's a variety of other VM images available. And here we see that they've created two steps for us. One step is a script calling "Hello World" in the output, and the other one is a two line script. Now you see as we start editing, we get the ability to basically predictive typing, but we don't want to use that. What we want to do is go over here, and if we go to the assistant, inside of the assistant, there's access to many existing tasks. And for example, later on, we're going to use a publish tasks that publish the HTML5 reports and publish to the pipeline artifacts. We might start using some of those, but for now, just for a simple demonstration, I'll show a bash task, and then inside the bash task, I wanted to create an inline script, and in that script, I want to say hello dev Oktoberfest. And then when I save and run this, it's going to commit to the main branch, and it should go off and trigger a build. You can see here it's triggering a pipeline job, and when we click on the pipeline job, it should once it's stopped waiting to be in line. Another thing with the free version, you have to wait for the resources to be available. You see that it's checked out the repository. It's ran the one-line script and said "Hello World," ran the multi-line script and said other task, other project, and it's didn't do our for some reason it didn't run our command. Oh, because I didn't save it. Let me just go back and pipelines. Leave. Go in. Edit. You just want to add that task, the bash task, and go inline hello dev Oktoberfest, and add it to the pipeline. You see there it's editable, and when we save this time and we commit, it should go off and run our command. One running. Let me just cancel that one. And come back in this one, and we can see the job. It's ran our bash And hello, Devtoberfest. Thank you. All right, so that's basically the demo of DevOps. And after you run your pipeline, you will get notified via email whether it was successful or not. And we can see here that it was successful. If it wasn't successful, we come in and have a look why. Now, let's go back to the presentation. So what we saw there was how to create a repo in Azure DevOps, also how to set up a pipeline for the repo, how the YAML was structured, how we incorporated available tasks, how we could search for available extensions in the marketplace, how the pipeline was triggered on commit, and how to see the results on the completion of the pipeline run. And now we'll start getting into something a bit more related to SAP CAP. So I'm about to show two examples. One example is a simple pipeline, which does a build and deploy. And then there's a more advanced pipeline, which would allow you to scale up to meet the needs of your specific application. So now let me click on this link. Should open up the repository. So it opens up this repository that I'm sharing, and in the repository, I outline where all the bits and pieces are. But I say this repository is intended to be used as a reference for how to build Azure DevOps pipelines for the use of SAP CAP, and it's got some benefits there about how CI/CD improves the CAP experience by faster feedback, quality and risk assurance, and team collaboration. It can gives you techniques for creating templates to use across many projects. This repository is actually a copy of the SAP samples CAP SQLite repository, which is basically a reference for how to go off and create Fury applications based on whether it be a CAP node or CAP Java. It shows you how to deploy to both Cloud Foundry and to Kima. Inside of here, we have some GitHub Actions and workflows that we leverage inside of our advanced repository. Let me just go up and show you when you deploy this application, it will deploy to the cloud, and then I basically brought the two applications into my BTP build launchpad, build workzone launchpad, and later on we're going to test against that. So back to the repo. First, we're going to cover off a simple pipeline. And so the hypothetical scenario is that we've got a developer, and the developer is creating a travel processing application. You saw the repo, the SAP samples repo has a travel application CAP application, and Sarah needs fast feedback on her changes to ensure that they can integrate seamlessly with the project. So we're going to provide a simple pipeline, the pipeline on push to the main branch. It's going to go off and build the MTAR and deploy the MTAR to Cloud Foundry. I'll go and demo. I'll show what that looks like in DevOps. So back to our pipelines. We go to the simple pipeline. We go and edit the pipeline, very similar to the pipeline we created before, but in this case we're we're declaring a container. Now, the container is using the Project Piper Docker container for the CF CLI, which is a Cloud Foundry client interface, the ability to deploy via the CF deploy command. We're triggering this build once again on the main, committing code to the main branch. This has got two stages, as a build and a deploy stage. In the build stage, we're basically once again using the default Ubuntu image, and we're going to pull down the code from the repo and then do an npm install, and we're going to run this command to build. In this case, we're building an mtar that has the SQLite database. I wanted the SQLite database so that I'm not going to get caught out if the HANA Cloud turns off on my free subscription. And then once the MTA is built, we're going to publish this to a artifact that's available in the pipeline, and that's the end of the build step. And then we're on to the deploy step. The deploy step only starts if the build step was successful. We've got a deploy job, and that job is going to use our CF CLI container. It's going to check out the. It's not going to check out the Git repo. It's just going to download the artifact, and it's going to run this CF Cloud Foundry command to log in, and then the Cloud Foundry deploy, which is going to read back in our mtar from that artifact folder. We're going to use these variables to populate the authentication. One thing to note is that if you're going to create environment variables to be used across many applications or many pipelines, you want to create a library of variable groups. And you can see here I've got variable groups for Cloud Foundry, for the Cloud Transport Management, and for end-to-end testing. And very similar to what you saw before, you just put in the user and password. Like normally you would use a technical user with least privilege, not necessarily an end user. If we go and have a look at that pipeline, how it looks when you run it, the two stages there, we can see the build and deploy took 4 minutes. So by automating, we're going to save the developers 4 minutes of their time, and it publishes the MTI artifact, mtar artifact, where it can be used on subsequent stages. Could actually be used in subsequent pipelines. Let's go and have a look at the run. Again, it's checking out the code. It's using the npm install. It's building the MTA archive. It's publishing the archive, and then it's going to deploy. It's not checking out the code. It's downloading the archive, and it's running the bash. At the end of the bash, we see the Cloud Foundry deploy multi-output logs. And if it was a failure, we'd come in here and we would run this from the command line to see why it failed. But in this case, it was successful, and that's essentially the simple pipeline. Now, if I go back to the repository, just the documentation goes into, once again, what we saw, the Docker CF CLI pipeline is included as a container resource. It runs the scripts from the package JSON that was provided. It deploys to Cloud Foundry, and then on success or on failure, you're going to get an email, and you click on the results. You'll see the results, and you can come in and see why something either passed or failed. So that's the simple pipeline. And now we'll go off and have a look at the advanced pipeline. Now, the advanced pipeline, there's a lot more to it. So the scenario is that we now have this processing application in production. It's been used by tens of thousands of users. There are high peak load times where there's increased demands of public holidays and special events where people want to do their travel booking. The development team understands the criticality of ensuring the application is in a running state, and therefore the pipeline requirements have gotten a lot more stringent. So I'll just show you the diagram for this. We have build, deploy, scan, end-to-end tests and upload. So very similar to a template you would find in the SAP BTP CI/CD service. In the build, we're now not just building, we're actually testing our code. So we're linting it, making sure that it complies with our coding standards. We're running some unit tests. Unit tests are ensuring that any new features we have in have got a test and some kind of coverage to ensure that we cover that test. We have some integration tests. Once again, all of this was provided by the SAP samples repo, and the integration tests are running the OPA 5 tests for those two applications. And then we're going to go off and build an MTAR, and the output is we have some test reporting and some code coverage reports. Then we go into the deploy. The deploy will be exactly the same. Onto the scan. So the scan is a security scan. Here we want to check both security and static code. So we're going to go and check the dependencies, make sure that we're not introducing any vulnerability, any kind of dependency like a log4j that might increase the chances of some kind of security incident. We're also going to ensure that we're not including secrets or passwords when we deploy our code, so we're not going to include it. And down here I've got the software bill of materials. Now, the software bill of materials in the next couple of years will become very important as a lot of government agencies, especially in the US, where President Biden has mandated that every SaaS provider, the provider of cloud software, needs to provide some level of comfort, be it via some kind of SOX 2 audit or via a software bill of material, which will explode down the list of all the dependencies and such that at the time the code was deployed or the time the code was changed, it included all of these dependencies, and basically we have a level of comfort that the process of the build and deploy are satisfactory. After that, we go into end-to-end testing. Now, end-to-end testing is more real worldy testing. So you saw before, we've deployed our application to the BTP work zone. Inside of here, we want to do some VDI5 testing against the work zone. We might want to do parallel testing both in a Chrome browser and an Edge browser. We have some K6 performance testing. Now, K6 is an API and load and performance testing tool written for JavaScript developers, very similar to JMeter, but it's written in JavaScript. It is very, very easy to grok and understand. And we in our pipeline, we have a simple scenario where we want to run performance tests for over 3 minutes and ensure that the load we're putting on doesn't decrease the usability for the user. So we're going to have a look at the metrics and make sure that the more load we put on, it's not impacting the user experience. And last, this is optional, is a browser stack, the ability to test our VDI5 developments across a number of browsers and runtimes. So with Browser Stack, we can test not only iPads and iPhones, but we can test Androids, we can test the different versions of browsers, be it Chrome or Safari. We can also test the different versions of the mobile operating systems, and that way we can give a level of comfort that when we deploy this code, that it still works on all these different devices. And the output here is a timeline report. A timeline report for both the VDI5 and the browser stack would either give some screenshots, or it could give a video recording of the end-to-end tests. And like I said before, the performance metrics for the K6 performance test will give us an overview of how well our changes performed against load. And last but not least, we have a upload stage which has an upload job which uploads the MTAR to the Cloud Transport Management service, and uploads to the QAS buffer queue, ready for us to move that MTAR onto other environments. So that's the continuous deployment aspect of it. So now let's go and have a look at that pipeline. So into the pipelines, advanced pipeline. If we have a look at the output, we can see here it's got those 5 stages. For the build stage, I'll just open up that same. I can have 2 screens running parallel. So here we can see the build stage. It's basically checking out the code. It's running the lint, and here we see there's a couple of warnings for the lint not erroring, so it was able to go on to the next step. We run our integration tests, the upper 5 tests, and we've got the output here. Now this is a unit test. We can run the OPA test. We see it's running in Chrome headless. We're building the MTA archive. We can see down the bottom, it successfully built the archive and put it to the archive folder, and we're publishing the archive. And here you can see we're publishing the code coverage, and we're covering the test results. Now, if I go back over here, we can see there's a tab in the runtime output for tests. Inside the tests, we can see that there was 22 passed, 95% success. One of the tests was skipped. If we go into the test run, and we can see if we change the, we can see the tests over here. Really? And if we change the, at the moment it's only going to show failed and aborted, but we change the pass, we can see, if we were to grab all of them, we can see that the individual tests are all successful, but if they failed, we could come in here, create a bug, and that bug would go in our to-do list on our Kanban board. So that's the test, the coverage. Note we don't actually have any code to cover in the Fury application. So this is purely testing the coverage of the CDS code, and you see here it's got 69% coverage, which is quite good coverage. You don't want to aim for 100% coverage. You just want to aim for the the most well-trodden features, like maybe the other 30% that haven't been covered, relates to edge cases, for example. So that's the build. Deploy we saw before, it works exactly the same. Only difference now is that it's using that environment variable group. The scan, we're doing a SNCC scan. So SNCC is a popular security tool, and it has a task that we can pull down from the marketplace, and that task includes the configuration we need to do security checks against our CAP repository, CAP development repository, and it also has the configuration for outputting a report. If I go back and have a look at the report, the SNCC report, here there weren't any vulnerabilities. We can see out of the 214 dependencies that came through the package.js, for example, all the npm repositories dependencies it's pulling down, that there were no vulnerabilities. Inside of the repo I'm sharing, it most definitely has a report that would show what it looks like if a vulnerability was found. So now let's just go back to our pipeline. We have the VDI5 tests. The VDI5 tests, this is a simple test using Chrome, and it's going to call our BTP work zone. It's going to perform a number of steps. It's going to create a new travel request. It's going to delete that travel request. At the end, after a minute of simulating user interaction, it's going to pass back that it worked. And then at the end of this, it publishes that timeline report I was talking about. So if we come over to the HTML5 viewer, go to the second tab. This is the timeline report for the VDI5 run, and you can see here that I've got the timeline report configured to take screenshots, and that's the VDI5 browser stack. I didn't include in here the browser stack. The free version only gives you certain amounts of minutes. I can show you an example of the browser stack working. So here I'm doing a parallel test inside of the browser stack output. It has the name of the session I created, and when I drill in there, it basically created a video, and I can go back and watch the video of how that VDI5 test worked. So it will run through exactly how the user would iterate. So here is creating a travel request. It's finding the agency. It's getting the customer. It's adding the start and end date and the booking information. Description is travel to delete. And it comes in, and last but not least, it's going to delete that. And at the very end, our VDI5 tests are complete. So that's the browser stack. So we covered off VDI5 tests and VDI5 tests running in the browser stack against many different browsers. Here's the K6 load test. The K6, as I was saying, I'll show it's a very simple JavaScript file that again simulates what we just saw, the creation of a travel request and the deletion of a travel request. It will continue to do the creation and deletion. Or in this case, I've set up the performance test for 3 minutes. During those 3 minutes, it has gone off and created a lot of travel requests and deleted them, and it's output the the report of the metrics into the pipeline. So if I go back and grab our advanced pipeline, go to the run, go to the HTML viewer. The first tab shows the K6 results, and you can see running the test for 3 minutes, he's done 3,600 requests, and the fastest request was 29 milliseconds. The slowest request was 3.24 seconds. 95% of all requests are coming back well under a second, so our performance is looking good. So that's the load test, and then last but not least is the upload to CTMS. We see here the job basically took our MTA archive and it deployed it to the our BTP transport management system, and you see here the QA node. It has the transport request 463, and it includes the description of the pipeline, or in this case the repository, and the description of the git commit, who did it. So it's automated, but it can see who made the commit, and basically that's uploading a MTA archive to our cloud transport management service. Now let's go and have a look at this pipeline. So if we come in and we edit it, it's going to be a little bit more complicated than the simple pipeline. At the top of the at the top of it we have the we're pulling down the project piper, SAP project piper's our Cloud Foundry CLI Docker image. We've got some toggles on and off to determine whether or not we want to run each of the different stages in their jobs. In this case, you saw before I had browser stack false. We are running a lot of the tests that were available in the repository. So if I go up here into the GitHub for workflows, there's a Node.js workflow, and inside of here, this repository already included some linting and some unit testing, as well as integration testing of both the applications. So I'm reusing that code. The only difference is that I'm outputting the logs for both the unit and the coverage, and I highlight in the repository how that is done, and similarly with the OPA 5 integration test to get the reporting. You have to do a small include of a dependency so that the logs are written such that the Azure pipeline can pick them up. Again, we're building the MTAR. Here we can see we're using the available task for publishing coverage report results, and you saw that was available in the run results. And similarly, we're publishing the test results, and here the coverage is in the coverage format. Here it's in the JUnit format, the format that's needed for the report. So here in the deploy is exactly the same as before, but we're using a variables group. So once again, we don't want to have the variables specific to this pipeline. We want to reuse them across many. We saw the security scan from from SNCC. Here I've created a template. Using templates are very easy. So if I go down to Azure repos into templates, there's a step template, and here's the template for that SNCC task. Like I said, the task is very simple. It does both the security scan and the reporting. So this is a very simple way of doing templating. After that, we've got our end-to-end tests. Once again, in the end-to-end tests, we're using a variable group. End-to-end tests depends on the scan. So if the scan fails, much like if the deploy fails, the scan won't work. If the scan fails, then we don't run the end-to-end tests, and we fail the job. Here we can see that the template specific for VDI5 tests. Again, I go into a lot more detail in the documentation, but here's the template for the VDI5 tests. Much like you would run VDI5 from a command line. So we can see in the package JSON, we have a number of VDI5 tests. We have a standard test. This is one we used in the pipeline. No, this is the one we used in the pipeline. But we also have tests for Edge and for Edge headless and browser stack. I could quickly go and show you an example of the VDI5 here, and I want to run Edge. Should start up. It should have started up 2 browsers. Right, I can come back to that. I just killed that. Not sure why that didn't work, but if I come over to the documentation, I share that exact scenario. So coming in and run the script, and it will basically create 2 browsers. One browser being Microsoft Edge, and the other one being Chrome, and it will run our VDI5 end-to-end tests and go through that process of verifying first smoke testing that we can actually use the applications, and then it will go through and go and create a new travel request. And once it's created the travel request, it will go and delete the travel request. So here I'm showing how simple it is to use VDI5 tests against a BTP work zone launchpad to verify the code changes you're making. Down here we see the results. Basically two runs, and they passed. Here's an example of how similar the VDI5 code is to OPA. It is very, very similar. Here I'm sharing that I have a number of different configurations, and here how to run those configurations within an Azure pipeline. Here's the output results. Similarly with the browser stack, showing how to configure the service connection for the browser stack, how to put in the API keys, how to configure the pipeline. And here's an example where I'm running with a lot more. So this is basically the documentation. Inside of the documentation, there is a lot more detail about how to configure the Azure DevOps pipeline, how to use templates. So if I go back up, there's a section here on how to use templates and put conditions in those templates. There's sections on SNCC and why you should use security scans, and shows you how to sign up for the free version of SNCC. And down the bottom here is the bit on upload to Cloud Transport Management. I had to write some JavaScript code, which essentially does the same job that Piper does to upload to CTMS. Here I describe what environment variables you need to have. At the top, I show the steps you need. First, you need access to a cloud transport management system, and then you need to go and create an instance key, and then we use the instance key to post via the TMS API. So this is in the API hub. How we use this cloud transport management API to upload the file. So essentially, that's the advanced pipeline, and we saw all the different outputs. And now let's get back to the presentation. So we saw the two examples of the pipelines. I went into very much granular detail on the simple pipeline. On the advanced pipeline, I showed basically what was possible. Trying to give a good understanding of as your requirements grow, what you might want to add into your pipeline. I shared the link to the repository. You saw inside the repository, it basically had enough documentation to enable you to go away and do for yourself. Wrong way. So in conclusion, we cover the simple pipeline, how to do the CI bit, how to build the app and deploy the app to Foundry. We saw an advanced pipeline which took the CI bit and added a lot more rigor with testing and with scanning. And we also showed testing end-to-end, where we were testing like a live environment as the user was used, to make sure that we're not lessening the experience for them. Inside the documentation, you saw I cover off how to create templates, how you can reuse templates across many applications, how CI/CD, hopefully, the takeaway is how CI/CD improves the CAP development experience by providing faster feedback, quality and risk assurance, and a better collaborative experience for all the developers. And last but not least, before I go, I want you to go and have a look at this repo. And if you've got any questions, you can raise issues against that repo. Or here's my contact information here. Here's my LinkedIn. John Patterson on LinkedIn. Here's my Twitter account. As I said, I'm a BTP Cloud Sherpa. I work with customers, helping them adopt new technologies like SAP CAP and how to get the most out of it by using things like Azure DevOps pipelines. All right, thank you.